Hello, how are you doing? If you're following our assignment calendar for April, you are on lesson 923, which is the assignment for Monday, April 27th. And today's lesson is on understanding square root. This is the symbol that you will most likely see when using square root of numbers. So let's start out with a definition. A square root of a number is a value that when multiplied by itself gives the number. So let's put that into the context of a problem. I think it makes more sense to see it that way. So here we have a square. It is a 4 by 4 square. If we were to find the area of this square, 4 times 4 gives us the area of 16 square units. So over here I have it written out in an equation. 4 times 4 is equal to 16. So a square root of 16 is 4. That means 4 times itself equals 16. It's also really important to remember that 4 is not the only square root of 16. Keep in mind, if we were to multiply -4 times -4, that would also equal positive 16. So -4 is also a square root of 16. Usually, when we're working with square roots, you are asked just to find the positive roots, but it is good to keep in mind that there are negative roots also. When working with square roots, it's really helpful if you are familiar with perfect squares. Perfect squares are the product, that means answer of a multiplication problem. Perfect squares are the product of a rational number multiplied by itself. So for example, if we multiplied 1 times 1, we would get the product 1. 2 times 2, we would get a product of 4. 3 times 3 gives us a product of 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. These numbers here, the product or the answer, when you multiply a number by itself, are perfect squares. Now, I just did the perfect squares up to 36. It's really going to be beneficial if you can memorize your perfect squares. Let's generate a list right now. I'm not going to write out the entire multiplication problem. Just continue the list of perfect squares here. So 7 times 7 is 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. 11 times 11, 121. 12 times 12, 144. 13 times 13, 169. 14 times 14, 196. 15 times 15 is 225. And you could keep going, 16 times 16, 17 times 17, etc. But I find that these perfect squares listed here are the ones that you most commonly use in our math work together. Okay, let's work on our first example problem. This example 1 asks us to find the square root of 6 different numbers. So let's go ahead and start with the first one, square root of 81. That sounds familiar because that number was just in that list of perfect squares that we generated. What number times itself equals 81? We are going to list the positive square root, 9. If the directions ask for the negative square roots, then you would list that also, but normally you're just listing positive roots. Now, square root of 84, that was not in our list of perfect squares. which tells me I'm going to need my calculator here because it's probably going to be a decimal number. So I grab my calculator, and on my calculator I have to enter the number first, and then the square root sign, which is this one right here. And it tells me that it's 9 point, and you can see it's a long decimal number. So we're going to stick with our general rule that we talked about in our last lesson with Pythagorean theorem. And I'm going to ask you to round all of your decimal answers to the nearest tenths place, or one place past the decimal. So 9.1, I look to the 6 and see, that really needs to round up because it's 5 or greater, which means the 1 is going to round up to a 2. So I would say the square root of 84 is 9.2. Square root of 150. I also don't recognize that as a perfect square, so I'll enter it into my calculator, select the square root sign, and it is a long decimal again, so we're going to round that to the nearest 12th. So it's going to be 12.2 for our square root of 150. Square root of 625. I have that one memorized, but it didn't appear in our perfect square list because it's much larger than the numbers that we use. So you could always use your calculator for this. Do 625 square root, and you see that it is a whole number. It's 25. Same thing with 10,000. What number times itself equals 10,000? You could use your calculator, or you might have that memorized. The square root of 10,000 is 100. And for our last one, I am certain that 24 is not a perfect square because I know 4 times 4 is 16, and 5 times 5 is 25. And 24 falls between those two perfect squares, so it's going to be a decimal number. So I grab my calculator, enter 24, square root, round to the nearest tenth, so I see that I'm going to be rounding up this time to 4.9 for the square root of 24. Okay, for example 2, we are asked between which two consecutive, and consecutive means the same thing as in a row, so numbers that are in a row like 5, 6, 7, between which two consecutive integers is the square root of 43. So let's think about what we know about perfect squares. Okay, we're looking for square root of 43 to be between two other numbers in a row. One that's going to be smaller than it and one that's going to be larger. So thinking back to our list of perfect squares, I know that 36 is a perfect square, and it's the closest perfect square that I have to 43, but less than 43. So I'm interested in square root of 36, and then if we think about what perfect square is larger than 43, but the closest larger perfect square, that would be 49. So we are interested in the square root of 36 and the square root of 49. So the square root of 36 is 6, because 6 times 6 equals 36. And the square root of 49 is 7, because 7 times 7 is 49. So it looks to me like the square root of 43 is going to be between 6 and 7. Now we could always use our calculator to check that. So let's see, what is the square root of 43? 6.5, etc., or it would round to 6.6, which is indeed between 6 and 7. Example 3. Between which two consecutive integers is the square root of 150? Okay. We know that it's going to be between two other perfect squares. one perfect square that's going to be smaller than 150, and one perfect square that's going to be larger than 150. So the perfect square closest to 150 but smaller than 150 was in our list that we did at the beginning of our lesson, and that is 144. And the perfect square that will be larger than 150 but closest to 150 is 169. Now let's find those square roots. What is the square root of 144, or what number times itself equals 144? And that is 12. What is the square root of 169? Well, I know that 13 times 13 is 169. So this tells me that the square root of 150 is going to be between 12 and 13. Now let's just check that answer by using our calculator. What is the square root of 150? It is 12.2. So it appears that our answer between 12 and 13 is correct. For the last part of our lesson today, we are going to move from talking about square roots to talking about cube roots. Now, cube root, the symbol is right here. It looks like the square root sign, but you can see it's got a little 3 right up there. So the cube root of a number is a value that when multiplied by itself 3 times gives that number. Let's look at an example. Here's a cube, and its dimensions are 3 by 3 by 3. So if there were little tiny cubes making up this larger cube, it would be 3 cubes across this base, 3 cubes going back, and 3 cubes tall. All together, there would be 27 little cubes making up this whole entire cube. 3 times 3 times 3 equals 27. And the way we write that is the cube root of 27 is equal to 3. Okay, so we have example 4 that's asking us to find the cube root of 3 different numbers. First we have, what is the cube root of 8? What number multiplied times itself 3 times? So a number gets multiplied by itself 3 times and the answer is 8. If we multiplied 2 times 2, that would equal 4, and times 2 again, that equals 8. So the cube root of 8 is 2, and instead of x's, we know that 2 times 2 times 2 equals 8. Okay. What number times itself 3 times equals 1? So 1 times 1 is 1, and times 1 again equals 1, so the cube root of 1 is 1. Okay. Last one, cube root of 125. What number times itself 3 times equals 125? It ends in a 5, so I know that that's a hint. It's got to be a multiple of 5, so let's just start with 5. What is 5 times 5 is 25. Times 5 again is 125, and there we have our answer. The cube root of 125 is 5. Okay, let's finish off our lesson by making a list that we can refer to of perfect cubes. So to start off our list, if we multiplied 1 times 1 times 1, as we did up above in the example problem, we know that the product or the answer would be 1. Also, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 cubed, or 4 times 4 times 4, is 64. 5 cubed is 125. 6 cubed, 216. 7 cubed is 343. 8 cubed, 8 times 8 is 64 times 8 again is 512. 9 cubed, 9 times 9 is 81, times 9 again is 729. And we will stop at 10 cubed. 10 times 10, which is 100, times 10 again, which is 1,000. Now that list, I shouldn't put a period there, I should put an ellipsis because we could keep going and going and going. But just to remind you, we had 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed, 8. You could also say to the third power, so you could say 8 to the third power instead of 8 cubed, 9 cubed, and the last one we're going to put in our list is 10 cubed. Alright, that's it for today's video lesson. Tomorrow your assignment is to complete the review preview problems, which are, I'll just write them right here so you've got them. Review preview 9-88, and the second review preview problem that you will complete tomorrow is 9-96. Just those two problems tomorrow. Thanks, you guys. Have a great day.